Hello and welcome to a new video on IGCSE Physics. Today we will be covering the topic of kinetic energy and potential energy. This belongs to the mechanics unit. So we will begin with kinetic energy questions. You should know that the rule for kinetic energy is EK, which means kinetic energy equals half mv squared, where v is the speed or the velocity of the object, but we only care about the magnitude, so just the speed is what matters, and m is the mass. So let's begin solving problems. The first problem says a lorry of mass 4,000 kilograms is traveling at a speed of 4 meters per second. The car has a mass of 1,000 kilograms. The kinetic energy of the car is equal to the kinetic energy of the lorry. What is the speed of the car? So let's start writing down our given information. I like to label my variables. So I'm going to say the mass of the lorry is equal to 4,000. The mass of the car is equal to 1,000. The speed of the lorry is equal to 4. And I want to know the speed of the car. Now, we also need to remember that the kinetic energy of the lorry is equal to half times the mass of the lorry times the speed or the velocity of the lorry squared. And the kinetic energy of the car is equal to half times the mass of the car times the speed of the car squared. We are given that these two quantities are equal. We are given that the kinetic energy of the lorry is equal to the kinetic energy of the car, and we are required to find VC. So you can either figure out the value of the kinetic energy of the lorry first, and then substitute it into the second equation. But mathematically, it's easier and faster just to write the two equations side by side. So we have half ml VL squared equals half MC VC squared. We already know that these two quantities are equal because the kinetic energy of the lorry is equal to the kinetic energy of the car. Let's begin to substitute variables. First, we can simplify the equations a little bit. We have half and half, so we can just cancel these out mathematically. Since they are on opposite sides of the equation and they have the same value, we can just remove them. Now let's begin substituting. So instead of ml, I'm going to write 4,000. Instead of VL squared, I'm going to write 4 squared. And this is equal to 1,000 times VC squared, which I don't know. I can either write VC squared or I can write like X squared or whatever. This is my unknown, which I'm trying to figure out. You can use your calculator, or you can simplify life for yourself a little bit. So we can cancel out these 3 zeros here with these 3 zeros here. And then we just get the following equation. X squared equals 4 times 4 squared, which is basically 64. So therefore, X, my unknown, which is VC, equals what? It is equal to the square root of 64, which is 8. And remember that this X is VC, which is the speed of the car. Therefore, our correct answer is choice C, 8 meters per second. A gas molecule strikes the wall of a container. The molecule rebounds with the same speed. They give you a diagram before hitting the wall, after hitting the wall. What happens to the kinetic energy and what happens to the momentum of the molecule? So this question is a conceptual question. It requires you to understand the difference between kinetic energy and momentum in terms of which one is a scalar quantity and which one is a vector quantity. Momentum, as we discussed in a previous video, is a vector quantity and it depends on the direction of motion. Whereas kinetic energy is a scalar quantity. It does not depend on the direction of motion. We are given in this question that the molecule rebounds with the same speed. Just a brief reminder, the momentum of an object, which some people use the letter P to denote, is equal to mass times velocity. The kinetic energy of an object is equal to half times the mass times the velocity squared. Which of these would be affected and which of these would not be affected by a change in direction? Of course, the momentum P will be affected by the change in direction since P is a vector quantity, whereas the kinetic energy will not be affected by the change in direction since it's a scalar quantity. Bear in mind that the actual values of M and V, or what we call the magnitudes of M and V, remain the same. We know that the mass is the same because hitting the wall does not change the mass of the molecule. And we know that the speed is the same because they said so in the question. So M and V, in terms of their actual values, they do not change. The only difference is that for momentum, this guy becomes negative after the collision. So if it had a momentum of 5, its momentum after the collision becomes negative 5. However, for kinetic energy, if it were 10 before the impact, it would stay as 10 after the impact, because we said kinetic energy is a scalar quantity, not a vector quantity. So the correct choice here is choice C. The kinetic energy stays the same, whereas the momentum changes. The diagram shows 4 bodies moving in the directions shown. The only forces acting on the bodies are shown in the diagram. Which body gains the most kinetic energy when moving a distance of 1 meter? So this question relates kinetic energy to work. The work done on an object is equal to the force times the distance. And if more work is done on the object, it gains more kinetic energy. So how do we evaluate the work? We simply multiply the force by the distance, and we are given here that they all moved a distance of 1. So the greatest work done basically depends on the greatest force exerted. So let's simplify the forces a bit. For choice A, the net force here is basically 10 up, parallel to the direction of motion. In this case, the net force is 15 to the right, also parallel to the direction of motion. For work, the force has to be parallel to the distance moved. So I need to make sure that the force exerted is parallel to the distance moved. Now, in this case, it is also 10 parallel to the direction of motion. So here, again, the force is 10. And in case D, the force is 0. So since in case C, we have the greatest force exerted, therefore we conclude that the greatest work is done, and therefore it gains the most energy. So the correct choice here would be choice C. An electron is moving at a speed of 5 times 10 to the power of 6. A neutron is moving at a speed of 5 times 10 to the power of 4. The mass of the electron is m. The mass of the neutron is 2000 m. And we want to know which of these has the greater momentum and which of these has the greater kinetic energy. Let's remind ourselves of the two equations. Momentum is equal to mass times velocity. Kinetic energy is equal to half mv squared. So for the case of the electron, we can say that the momentum of the electron is equal to 5, before the 5, let's write m, because the mass of the electron is m, times the velocity, which is 5 times 10 to the power of 6. And the momentum of the neutron is 2000 m times, the dot here denotes multiplication. It's not a decimal, it's multiplication. 2000 m times 5 times 10 to the power of 4. And we are asked which of these has a greater momentum to begin with. So which of these two quantities is greater? They both have m. Let's cancel things out to compare. So they both have m. We don't really care about the m. They both have 5. This has 10 power 6, and this has 2000 times 10 to the power of 4. So if I write this in scientific notation, this would be 2 times 10 to the power of 3 times 10 to the power of 4, which is the equivalent of 2 times 10 to the power of 7. Hence, 2 times 10 to the power of 7 is obviously greater than just 10 to the power of 6. So the Pn is greater than Pe. Let's repeat the same process for the kinetic energy. The kinetic energy of an electron is equal to half times its mass times its speed, which is 5 times 10 to the power of 6 all squared. The kinetic energy of the neutron is equal to half times m times, excuse me, I made a mistake. It's not half times m, it's half times 2000 m. This here is m, but this here is 2000 m multiplied by 5 times 10 to the power of 4 all squared. And again, we want to compare these two quantities. So let's get rid of the common variables or constants. So I can just cancel out the half and the half. I can also cancel out the m and the m. But I need to know that 5 times 10 to the power of 6 all squared is actually equal to 5 squared and 10 to the power of 6 all squared. So the 5 becomes 25. And the 10 power 6 becomes 10 to the power of 12. It's 10 to the power of 6 to the power of 2, which gives me 10 to the power of 12. Let's do the same for the one below. 5 to the power of 2 gives me 25 times 10 to the power of 4 to the power of 2, and this gives me 10 to the power of 8. Now I need to compare again. Again, I have 25 and 25. Let's just cancel these out to simplify life for ourselves. We are comparing now between 10 power 12 and 2000 times 10 to the power of 8. So I have 2000 here, and I have 10 to the power of 8. If we rewrite this in scientific notation, we get 2 times 10 to the power of 3 times 10 to the power of 8, which is 2 times 10 to the power of 11. So in this case, the kinetic energy of the electron is greater because 10 to the power of 12 is greater than 2 times 10 to the power of 11. Hence, the kinetic energy of the electron is greater than the kinetic energy of the neutron. So we choose the choice that suits our findings. We said that the electron has a greater kinetic energy. whereas the neutron has a greater momentum. So the correct choice here would be choice C. Based on what? Based on these two findings here, momentum of the neutron is greater and kinetic energy of the electron is greater. So the correct choice here is choice C. An aircraft with a mass of 300,000 kilograms is flying at an altitude of 2,000 meters with a speed of 100 meters per second. What is the kinetic energy of the aircraft? So this is an easy question. Kinetic energy is equal to half mv squared. Perhaps the only trick here is that they gave you more information than what you need. This is irrelevant. I only care about the mass and the speed. So half times 300,000 times 100 squared. And you can use your calculator. This should give you 1.5 times 10 to the power of 9. Yes, 1.5 times 10 to the power of 9. But bear in mind that this is not in any of the available choices. So what did I do wrong here? Did I do anything wrong? Well, this is the kinetic energy and it's given in joules. However, all the choices are given here in kilojoules. So how does that change anything? Kilogram, kilojoules, kilometer, anything with the subscript of K before the unit means 1,000. So kilogram is equivalent to 1,000 grams. Kilojoules is equivalent to 1,000 joules. So the correct choice here would be choice B, because you need to multiply all the choices by 1,000 to get your answer. So this is equal to 1.5 times 10 power 6 times 1,000 to convert it from kilojoules to joules. And that gives us 1.5 times 10 power 9, which is the same as what we got. So the correct choice here is choice B. Two cars P and Q have different masses and different speeds as shown. Which row correctly compares the momentum and the kinetic energy of P with the momentum and the kinetic energy of Q? We solved a similar question before. Just a quick reminder, P equals mv, kinetic energy equals half mv squared. So let's compare. So the momentum of P is equal to the mass times the speed or the velocity. So 1,000 times 10. And that gives us 10,000. The momentum of Q is equal to 500 times 20. And again, that gives us 10,000. So we know for now that the momentum of P is equal to the momentum of Q. Kinetic energy of P is equal to half times the mass, which is 1,000, times V squared, which is 10 squared. And this gives us the following value, which is 50,000. Kinetic energy of Q is equal to half times the mass of Q, which is 500, times the speed of Q, which is 20 squared. And we calculate this. And that gives us 100,000. So therefore, from our results, we conclude that the momentum is equal in both, but the kinetic energy of Q is greater, or in other terms, oh, excuse me, I made a small mistake here. I missed 1 0. It's actually not 100,000, it's a million. No, never mind. It's 100,000. Yeah. Okay, we're good. So this value is greater than this value. I just misread the number of zeros here. So anyway, we conclude that the momentum is equal in both. However, the kinetic energy is greater in Q. So the correct choice here is choice C. An object has a mass of 500. It moves with a speed of 30. What is the kinetic energy? So this is a simple question. The kinetic energy here would be half times the mass, which is 500, times the velocity squared. And we just use our calculator to figure this out. I typed it into the calculator. I got 225,000, which is equivalent to 225 kilojoules, as we said before. This concludes our questions on kinetic energy. We shall now move on to questions about potential energy. And the equation for potential energy is EP equals mgh. Again, EP here denotes potential energy. M is the mass, G is the gravitational constant, which is equal to 10 or 9.8, and H is the height of the object. An object is in free fall. The change in gravitational potential energy of the body depends upon its mass, the change in height, and the gravitational field strength, which is exactly what we just said. What is the correct expression for the change in gravitational potential energy? So as we just explained, the gravitational potential energy is mgh, or more accurately, mg delta h. This triangle here is called delta, and it means change. Because potential energy is measured relatively. So we do not care about the actual height, we care about the change in height. But this is a bit of an advanced concept. You don't really need to worry about it for now. So anyway, the correct choice here would be choice A. Pendulum bob swings from W through points X and Y to Z, and then back to W. Which statement is correct? The gravitational potential energy of the bob is smallest at W, or smallest at X, or smallest at Y, or the same at all the points. Since the gravitational potential energy depends on the height, we expect it to be smallest at Y. So therefore, the correct choice here would be choice C. Car of mass 800 kilograms travels over a hill of height h. By traveling to the top of the hill, the car gains 40,000 joules of gravitational potential energy. The gravitational field strength G is 10. What is the height of the hill? This is a simple application of the rule potential energy equals mgh. And like we said, more accurately, we should say mg delta h, but we can just ignore that for now. The m, as given in the problem, is 800. The gravity is 10, so we multiply 800 by 10 by h. All of this is equal to the gain in potential energy, or again, the change in potential energy, which is 40,000. This is a simple problem. All you have to do is divide 40,000 by 800 times 10, which is basically 8,000, and you can get your answer. I assume the height here will be 5. So the correct choice would be choice A. The student runs up a flight of stairs, which information is not needed to calculate the rate at which the student is doing work against gravity. So work against gravity is another way of describing gravitational potential energy. Gaining gravitational potential energy happens by doing work against gravity. This is why climbing up the stairs is much harder than climbing down the stairs. So what information do I not need? Bear in mind that the word rate means that we're describing this with respect to time. So this word, the rate, means that we have to obtain some value of the time. And we said that work against gravity is equivalent to potential energy. So basically, we need m, g, and h. So do we need the height of the flight of stairs? Yes. This is h. Do we need the time? Yes, we said that rate means that we are going to need some value for t. Do we need the weight of the student? Yes, the weight of the student is m times g, and we need both those values. What do we not need? We do not need the length of the stairs. We do not care about this value, the diagonal. That doesn't really help us. If we have the height, we don't really need the length. We don't care about the distance as much as we care about the height that the girl gains by climbing the stairs. So the correct choice here is choice B. This is the only piece of information that we do not need. A barrel of mass 40 kilograms is raised to a height of 1.5 by rolling it up a ramp. The length of the ramp is 8. The force F applied to the barrel acts parallel to the ramp. The frictional force is negligible. Which row is correct? So this is a combination of two concepts. We are required to figure out the gain in the gravitational potential energy and the force done. So we're going to need two equations here. Gain in gravitational potential energy, which is mgh. And we're also going to need the equation work equals force times distance, which we previously mentioned in this same video. Let's figure out how to do this. So to get the gain in potential energy, I'm going to use the mass, which is 40. And it's raised, first gravity, which is 10. And it's raised to a height of 1.5 meters. So the h value is equal to 1.5. So the gain in gravitational potential energy here is 600 joules. You should know that the gain in gravitational potential energy is obtained by doing work against gravity. So there sort of needs to be a force applied in order to obtain this increased gravitational potential energy. In our case, when we're climbing the stairs, we exert a force to move up the stairs. That's why it's harder for us. It's more of an exercise because we're doing work against gravity. And like we said, work is equal to force times distance. And we have the distance already. So the distance here is actually equal to 8. We do not have the force. And we said that the work done is equal to the gain in gravitational potential energy. So in order to get F, I simply divide 600 by 8. And that gives us the correct answer of 75 newtons, of course. So the correct choice here would be choice C, 600 joules and 75 newtons. And this concludes our video. Thank you for taking the time to watch. I hope this has been of some value to you.